Hi guys, so here we're going to talk about different density concepts and calculations. You'll need your notes, table T, table S, and your calculator as well. We're going to talk about what density is, how to compare density values, how to determine what density is in lab, calculating it, and giving you 2 examples for each of them. So density is an intensive property, meaning that it doesn't matter how much of the sample that you have, but the density itself will always stay the same. So the density of aluminum in one sample will always be the same as density of aluminum in a different sample. It's pretty much how tightly compact or how much matter is in a certain amount of volume. So if you look at the pictures down below, in here we have 2 cubes. They are the same volume, but the amount of particles are different between the two. We know that these are 2 different samples of 2 different objects. So even though their volume's the same, their particle arrangement, or their particles are going to be arranged a little differently. The one on the left-hand side has barely any spaces between the particles. They're really close together. However, the particles on the right-hand side are pretty spread apart pretty far. The diagram here on the right, again, shows you another picture of something that has high density versus low density. The high density have the particles packed in tightly together. There's barely any space between them. But the density on the right-hand side, or the item on the right-hand side, has low density. There's pretty much space between those particles that are arranged randomly. If you have or need to find the density for any particular element, it's listed for you on table S. So this is table S. It gives you the atomic number, which we haven't talked about yet, but that's fine. You at least can have the name of each of the elements listed for you here. And all the way over here is all your densities. Notice that they have units, grams per centimeters cubed as well. So for example, if we wanted to find sulfur, it has a density of 2.00 grams per centimeters cubed. So looking at comparing different densities, something that is more dense will sink than something that is less dense. So water has a density of 1.00 grams per milliliter, or 1.00 grams per centimeters cubed. Make sure that you remember that. That is a very important number to know. Luckily, it's very easy to know. But that means that if you have 32 milliliters of water, that's also equal to 32 grams of water. That's a very helpful thing to have. And that's usually at standard conditions as well. So let's take a look at this column here. We have a whole bunch of different items in here, and it shows you how they form different layers. So all the way down at the bottom, we have honey and a little bolt down below. The next layer is corn syrup. So we know that corn syrup is less dense than honey. Maple syrup is less dense than corn syrup or honey, and then milk is less dense than those, and so on and so forth. So water is here, it's colored green, so you can see a little bit differentiate between the vegetable oil. But water is going to be more dense than vegetable oil, and that kind of makes sense. Vegetable oil floats on top of water because it is less dense. Those particles aren't as compactly arranged. And all the way at the top here we have a little ping pong ball. So compared to all of these items, the ping pong ball has the least amount of density because it's floating. So let's figure out how to determine density in lab. You need to know the mass and the volume. Well, luckily the mass, you can use the electronic balance, but let's recall how to figure out volume. If it's a geometric figure like a cube or something that's rectangular, you can easily find the length times the width times the height. That gives you the volume. But in this case, we have a sample of something that is not geometrical. It's not a complete geometric figure, meaning it's not like a cube. So instead, we used water displacement. We figured out what the water was before we added the substance, and then what it was after we added the substance. So that difference is the object's volume. So to calculate density, we have density is equal to mass over the volume. Use grams for mass, or use and use milliliters or centimeters cubed for volume. Make sure that you remember those two. I won't always tell you which one the mass is or which one the volume is, so you just have to use the units to help you figure that out. We also need to know how to rearrange the equation. So for example, if we needed to solve for mass, if mass was our unknown, we'd want to put it on the left-hand side of the equation and then figure out what would be on the right-hand side. We can put density over 1 and then use cross multiply and divide. So since mass is on the top, we'd actually multiply those two. So mass is equal to density times its volume. Say, for example, we need to figure out what volume was, if that was our unknown. You can still put density over 1. And some of you guys do this a little differently. I know for me, I just move volume up, and if volume went up, density went down. Or you can cross multiply and divide, so density over 1. So you can have mass times 1 is mass is equal to density times the volume, which is what we just figured out. But if you want to isolate the volume, divide both sides by the density. So now volume is equal to mass over density. So that's how you'd rearrange the equation if you wanted to solve for volume. Let's do some examples. So example 1, an unknown metal has a mass of 148.6 grams. Using water displacement, the water was initially 50 milliliters. After placing the metal in, the water level rose to 135.4 milliliters. What is the unknown metal? So we want to make sure that we write down what each of the knowns are. So I have the mass is equal to 148.6 grams. And mass and grams checks out, so that's good. And the milliliters, or the volume. Well, this time they used water displacement, so let's remember, if the water was initially at 50 and it rose up to 135.4 after putting the metal in, that means that we subtract. We take 135.4 milliliters minus 50 milliliters. And this is all the work that I would expect you to do as well. Below that, you can see that when you subtract the two, it ends up being 85.4. Let's make sure that we have proper sig figs in there as well. It ends up being proper sig figs in there. Alright, so we know the formula's density is equal to mass over volume. We have the mass, it's 148.6. And we know the volume is 85.4 milliliters. So we just have to plug this into our calculator. At the end, we want to make sure that we have the right number of sig figs. So the mass has 4 sig figs, the volume has 3 sig figs. So at the end, we want to make sure that we have 3 sig figs in our final answer. When you divide this, it should just give you a whole big number, but for 3 sig figs, it ends up being 1.74, grams per milliliter. Make sure that part's boxed. Let's check to make sure we answer the actual question, though. The question itself is, what is the unknown metal? So just give me the number isn't what I need. I need to be able to figure out what this metal is. So I can use table S to help me figure out. I remember it was 1.74, so I can scan through table S, and there's 2 pages of table S, so just make sure you go through them. Look for the density, or look in the density column. So go down, and right here, 1.74. So the unknown metal is magnesium. So I'm going to go back up and erase everything that I had, which is unfortunate, but you at least have it. You can go ahead and write down magnesium. Or the symbol, which is Mg. Alright, so let's keep going. The second example says a sample of silicon has a mass of 21.7 grams. What is the volume? So they're not really giving us much here. We have the mass is equal to 21.7. We want to figure out what the volume is. In order to do that, we have to know what the density is. We know that they told us it was silicon. So let's go up and go to table S. Let's find silicon. There we go. Alright, that's what we want for density. So it's 2.3296. So let's write down the density is equal to 2.3296. Make sure I'm correct. That's grams per centimeters cubed. It tells us the mass is 21.7 grams, and our volume is our unknown, or it's our x. So let's look at the equation. Density is equal to mass over volume. To isolate the volume, put density over 1. So you can have mass is equal to d times the v, or density times the volume. Divide both sides by density because you wanted to get volume all by itself. So volume is equal to mass over density. So the mass is 21.7 grams, and the density is 2.3296 grams per centimeters cubed. We also know that we can get rid of grams because we have grams on the top and on the bottom, so we can cancel them out. So your answer, let's see, how many sig figs do we want? There's 1, 2, 3, 4, 5 sig figs for density, but 3 for mass. So your volume should only have 3 sig figs. So your volume should be equal to 9.31 centimeters cubed. There we go. Now, whenever we're doing these problems, make sure that you follow kind of the same format. On the left-hand side, I have my knowns and my unknowns. I started with my equation and then rearranged it, plugged them all in with their units, and then finally gave an answer with the proper units and a box around it. So make sure you have all of these. Also, if you are using lined paper, you're not constricted by my screen. So normally I would have the answer right down there underneath, but unfortunately I didn't have enough space. So if you are able to rearrange the equation, you can skip this step here, but until you get used to it, put it in there just so that you have it. All right, kiddos? And let's see. So to summarize, density is how compactly arranged the particles are. It's mass over volume. The mass is in grams. The volume is in centimeters cubed or milliliters. If you need the density of a pure element, it's given to you on Table S. Have a great day, guys.